Welcome. This is another Tactical Technician video brought to you from Diag Nation. Basically, the title of this video is Evap, but you don't see anything written down as far as what you can see is an Evap system. This is a very commonplace style Evap system. We have the fuel tank, we have the canister, we have the fuel tank pressure sensor, we have the purge valve, we have the vent valve, we have the PCM, and we also have a scope with 4 channels hooked up. And what we're going to do is we're going to kind of monitor this system with the scope. Not to say the scan tool isn't an excellent way to do it. This is just sort of a validator, kind of I don't know if it's a last resort, because it kind of proves everything directly and quantitatively as opposed to the process information of a scan tool, which is very good nonetheless. So take a little screenshot of this and I'll explain what we're doing here. Channel A is the WPS 500, and I'll show you that as I walk around. That is on the fuel tank, on the fuel filler neck. Channel B is at the fuel tank pressure sensor signal at the PCM. Channel C is at the purge solenoid control at the PCM, and channel D yellow is at the vent solenoid at the PCM. We also are going to do a little bit of bidirectional control, but it's not bidirectional in the scan tool sort of terminology. We're going to kind of come in and use jumper wires to open and close solenoids at different times to see the reaction, see the pressure reaction, see the solenoids work. So as you can see right here we have on the green channel, we have I'll show you the piercing probe. One end of it is a scope lead, the other end of it is a jumper wire, along with the yellow, with the yellow channel too. So basically our solenoids are going to be, we're going to take control of those solenoids, the vent solenoid and the purge solenoid. Purge solenoid is the front door of the system. That opens to let intake manifold vacuum in to pull the hydrocarbons out from the canister and in to be burned, so they're not wafting into the atmosphere. It tests itself during the monitor by doing various things, closing the vent solenoid, opening the purge, closing the purge, washing for decay, and things like that. I will get the thing running, and I will show you what I'm going to do. We're going to watch the pressure change as we open and close the purge solenoid. There is my T-fit, yeah, right there. You can see that's a really good piercing probe. I have the scope channel on going in one end and the jumper lead coming out the other end. You can see the green and the yellow. Those are our vent solenoid and our purge solenoid. So let me close the door and we'll get around. Here's my my setup. Basically, this is the WPS 500 in range 3 in inches of water. That little yellow doohickey is not cheap. It's really good though. So we're going to get on the scope and let's start kind of from scratch. Basically, let's make sure we got a good level camera now. We don't want any cockamamie cameras. So okay. Okay, you can see that. You can see everything, I hope. Okay, you got the scope. I will start the car, and I'll explain each, kind of go through let the system work in its natural state. I will start the scope. And basically we have a channel blue is the WPS 500. That is in the gas tank on the top of the filler neck on range 3. We're going to be dealing with inches of water. I just want to be mindful that I never go outside the range. I'm going to say 3/4 of a PSI, which is about, I don't say 20 inches H2O either way, to the north with pressure or to the south with vacuum. These systems don't deal with a ton of pressure. I don't want to collapse anything or cause any safety issues. So you should be mindful if you're ever using, as you're using another source like a smoke machine or a hand pump, that you stay within like a 1 PSI kind of a range there. So channel B is at the fuel tank pressure sensor, and if you look back at your schematic, and I apologize for not bringing this out, there's some numbers in the. Well, no, I didn't do this. I'm sorry, that was on another schematic. This is about 2.5 volts. Right here is kind of where a Honda rests at with neither pressure or vacuum in the system. When it goes south of 2.5 volts, it's in a vacuum. When it goes north, it's in pressure. I believe the conversion is 2.5 volts is atmospheric. 2 volts would be -8 inches H2O. 3 volts would be a positive 8 inches H2O. 14 negative inches H2O is about 1.5 volts, and then I'm kind of zigzagging, I apologize. 3 volts, or maybe 3.5 volts is 14 inches H2O to the positive. But nonetheless, okay, we just started a purge here. That's our natural purging going on, and we can see that they do purge at idle. Maybe not a big duty cycle, but we see some action. We see our pressure. I'll stop the scope. We'll kind of analyze it. We've got the purge kind of open. That's a pretty good duty cycle. I'm going to say, well, that looks like that's quite a bit. Nonetheless, I could make a math channel. I won't, but then you can see that's almost maybe 50%. We got a swing on going down on the blue, which is the WPS 500 range 3, and we also got our fuel tank pressure sensor. That's part of the car going down too, and it's kind of making sense. It looks accurate. The pressure sensor is in touch with reality. It's reacting to the duty cycle of the purge solenoid. The vent solenoid is kind of laying dormant. It is open. The system is open now, so it doesn't get a whole lot of vacuum in it. And we'll see that when I start to take control of the purge and the vent solenoids one at a time, and we'll see the action-reaction of a purge opening or a purge closing, or a vent opening or a vent closing. So nonetheless, we'll get back to right here, and we're still idling. And we can see the pressure in inches H2O, the vacuum. It's not a whole lot. Let's kind of run a cursor down here. That is very, very, very low. Almost about 2.5 inches H2O. What is our voltage? Voltage is about 2.45, and that's pretty much normal. If you do this, I know that from working in the Acura world with the factory HGS scan tool, when you run this test with a scan tool, right when it starts to duty cycle in its natural running state, you get about 2.45 volts. That's a very little bit of vacuum in the system because our vent solenoid is open, so it really is not be able to pull into a pretty intense vacuum. So I'm going to start to do some things here, and what I'm going to do first is I'm going to open the purge solenoid sort of wide open. I'm going to override the PCM, and we'll see what happens to everything here. So right here, we're going across the scope, and I'll start fresh here. Okay, look at that. I did that a few times. Okay, got a little bit of change there, not much, because we still have an open vent solenoid. So I'm going to give it some throttle to kind of slightly get more vacuum, because I'm in park now. I want to get a little more vacuum. And we drop. Okay. Okay, we can see a little bit of change there. Not a whole lot. I don't think we're seeing as much as I would expect. Okay. All right, I'll stop the scope. We'll kind of analyze that. We can see, we see some changes. We'll roll it back and see what we got here. So you can see right about here, I opened I took control. I overrid the PCM. So we got a little bit of a drop, not a whole lot. So let's kind of look at the green voltage first. We still have an open vent. So we dropped to about 2.3, which isn't much. And as far as inches of water, we were here, and we dropped about not much to about 3.92 inches H2O. So let's turn the scope back on, and now I'm gonna ground open the vent. I'm gonna close the vent solenoid. And you can see right here, Now we go. So we see this is up the okay, there we go. Okay, I'm gonna stop the car and we'll analyze that and see what we did here. We'll kind of you can see the effect. See the wild swing on that pressure with the WPS 500. We are going down, 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 and the also the pressure sensors on the vehicle is also going down. We're actually in its natural, when I say natural state of pulling on the system, not the vent. The vent I took control of, but the purge is basically the PCM's doing that, and it's not and it's got its duty cycle, and it's able to pull the thing into a negative pressure, right, like that. So let me get back here and get back into I'll take a measurement right here, and this is the lowest we go. Okay, that's a pretty good swing. That's a really good swing. That's about 15.4 inches H2O. That's about I'm going to say it's 27 inches H2O was 1 psi. That's a little over 500 milli psi or over half a psi. That's a pretty good swing. That probably tells us that we're leak free. That's how the PCM checks the Evap system when it's running its monitor. But nonetheless, I'm gonna get it back on. I just want to do some more dynamic stuff so we can kind of fish out an intermittent problem in this technique here. We're gonna kind of activate the system. I'm gonna kind of play with it off and on and watch how things change. So the okay, right here we got nobody grounded. I'm gonna kind of toggle the okay. You can see here. I'm just kind of playing with the purge solenoid, and I want you to look at those swings. On, off, on, off. And we got good crisp transfer points. And that's a good thing. That tells us a lot about our purge solenoid. That when we're opening, and when we're closing, we're closed. Because that's how it monitors. We don't want to once that thing seats and closes, it wants to stay closed, not to leak anything off. So right here we can see a good example right here. Our purge is open and we pull it down, the purge is closed here and we open it, and we can see that pressure going down into a vacuum. A nice crisp transfer point, no dancing, not too much anything where it would imply that the purge is sticking open or closed intermittently. We also see the fuel tank pressure sensor on the car go down also. Right here we see another one. We see our pressure going down. We see our purge solenoid open, voltage going low, pressure going down, 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 along with the red channel. And then right here it starts to go up because we take vacuum out of the system. We close the front door of the purge solenoid. So let me get another one going, and I'm going to actually do the vent solenoid like I just did that purge to watch its little sections. I'm going to do this. Here we go. We want to look at what I want to do is I want to get a longer time base because I think this thing's moving so fast. Relatively speaking, I want to go to 1 second per division, and I'm going to open the purge. Purge is open. Purge is closed. Let's see. Okay, vent is closed now. Up. Okay. Vent's closed. Purge is open. Purge is closed. Purge is open. Purge is closed. See that? Okay. Open the vent. See what happens. Okay. See, we're swinging up now. Okay. We're just watching the action-reaction of opening and closing those doors. Let me stop the scope. We'll roll it back. And you can see right here, we got a closed vent. Then we open the front door and wing pretty low, pretty quick. That's a good indication that we're tight. Right here, the purge solenoid, the purge solenoid closes, and no more vacuum is pulling on the system, so it kind of levels out here. We don't see a descending pull, obviously, because we have no more vacuum. That's a good indication of a good sealing purge solenoid right here. See that transfer point is right in line with the solenoid closing and the vacuum kind of equalizing. So we're not burning off too much this way. That would imply a good size leak. That's kind of how the PCM monitors this system. So let's get back to normal running. And I do have a check engine light because the PCM is probably not too happy with what's going on, which is it's doing its job. Sorry about the jingly camera. Okay, come on. All right. So I'm going to make a little change here. I'm going to get rid of the channel 2 with as far as a pressure the fuel tank pressure sensor. I'm going to put an amp clamp, like I said, on channel B, and I'm going to go around. I'm going to look at the current flowing through these solenoids one at a time. So here we go. We're going to kind of look at the action reaction. Okay. Okay, we'll start with the purge solenoid. We're going to look at current flowing through the. Let me change the menu on the channel because we're using an amp clamp. 30 amp clamp. And these things don't pull a whole lot of amperage, usually about 400 mil as we see. We're going to go to, how about 1 amp? And then now we got the amp clamp going. And we're going to take a look. Let's get our bearings here. We got our pressure. There's our WPS on our Evap system. Green is our purge solenoid, which is closed right now because we got a high voltage. Our vent solenoid is also closed because we got a high voltage. So we're kind of going across the screen. Our red is current, which is not flowing yet, but we'll start out and let's see what happens when we ground the purge solenoid. You see that off and on. I'm just kind of grounding it off and on. We got a good action reaction. We'll talk about it. Okay, I'm gonna stop the car and stop the scope. We'll talk about it. Well, actually, I'll leave the car running. It's a little hot today. There's, as I said, red is our current, and we got what we always want to feel is our pintle hump. I can see it. That's a good validator of physical movement within that solenoid, which is real important. That opens to let vacuum into the system. We're going down with the vacuum, and I'll measure it. That's right there. That's about minus 3.2 inches H2O. Our vent is still open as we see high. Obviously, our voltage and our current are corroborating. They're kind of it's the same electricity. Basically, our voltage going low at the PCM, current flowing through the solenoid right here, and then our pressure swinging low. Let's kind of do one with the the current going through the vent solenoid. I will switch it up. So let's watch that, and we'll almost end this thing. Current flowing this way. All right. Let's kind of look at our action reaction. Okay, what do we got? Well, we got current flowing, we got voltage going low, we got no pressure. This is obviously, let's think about that. And we see that we got no pull on vacuum because you know what? We got a good sealing purge solenoid, and that tells us a lot. So we can kind of infer that we like our purge. That's how the PCM checks it, by not seeing vacuum, by testing that purge solenoid is properly closed. You'd get a code for a high purge flow or improper purge flow. So basically you can see the vent solenoid closing, current flowing through the vent solenoid, and the purge solenoid, its door is closed. Let me open its door. Let me, okay, see that right here. We're opening the purge solenoid, and our pressure is changing. Let me get the amp clamp on the purge solenoid to kind of prove out the solenoid in the current flow. Okay. Oh, you see that right there? Okay. Okay, right there. Basically, we have current flowing through the purge solenoid. We see the, I'll stop the scope, roll it back, and we see the pressure go down. Our vent solenoid is open, and we know that we have good current flow, as indicated by our pintle hump. So basically, this system's about action-reaction, and let me just show you one more thing, and that's let's measure the current flowing. These things usually flow around 370 milliamps. And that's a pretty good indication. That's a healthy solenoid. We're not highly resistive or we're shorted, so we can see that. We can see our purge solenoid going low. I pulled it low. The pressure decreased. It went into more of a vacuum. Current flowed through the solenoid, and that's basically a good way to monitor this system with a scope. It is longer to set up than a scan tool. We realize that, but nonetheless, if you really want to prove something out, you can do it this way. You can also put your amp clamps on the wire going into the PCM and do the bidirectional stuff. Then you kind of prove out everything. You'll prove out the driver in the PCM and the wiring and the solenoid and the power feed to the solenoids. So anyway, signing off from Diag Nation. Thank you very much.